This is number 3 of exercise 4.3. Here we're going to observe the effects of molecular weight and concentration gradient on diffusion rate. So we have our 3 agar plates that are in front of us. And we will have 0.0% methylene blue, 1% methylene blue, and 0.1 of potassium permangate. We will use 1 dropper. And we have labeled the dishes A, B, and C. First, we're going to create a well in each of the agar. We're going to do that by using the dropper, and we're going to go right in the center and suck out the piece of agar. And then the last one. Alright, agar has been removed. Now we have little holes dug into the agar that we're going to fill with a different dye. So in dish A, we're going to fill the well with 0.1% methylene blue. Put it right in that little hole. There we go. Dish 2, we will fill with 1% methylene blue. And 3 will be the 1 of potassium permangate. Now we will measure over time. The first amount of time we will watch and measure is for 15 minutes. So I'm going to set a timer for 15 minutes and let you see what that looks like in 15 minutes. This is our first 15-minute measurement. We're going to measure each dish and record our data on our table 4.4. So the first one is A, which is the 0.1% methylene blue. We're going to measure just the distance. So actually we'll do it's about 1.2 centimeters. So we'll record that in millimeters. So that is 12 millimeters for A. And for B, which is our 1% methylene blue, that is 1.5 centimeters for our distance. So that's 15 millimeters for B. And then for C, we're going to measure that, I guess this way from the center. And that's 2 centimeters, so 20 millimeters for distance. So go ahead and record those 12, 15, and 20 millimeters For your distance, made it to the 30-minute mark for reviewing the molecular weight, activity, and concentration gradient. So you can see our different dyes, and we're going to measure them. So we're going to give you an overview. See, they're not moving too much over time. So remember that. So let's measure them real quick. First one is about the same. So 1.2, so 12 millimeters. About 1.6, so 16 millimeters. And then the last one, which is C, is 2.3, so 23 millimeters. So we will measure again at 45 minutes and then at 60 minutes. Make sure you're filling out your table. I just kind of made a makeshift one because I don't like to write it in my textbook because it's different every time for every assignment. And we'll check back in at the 45-minute mark, and we are going to measure A, B, and see if there's been any significant changes from 45 minutes from initially dropping dye into the well in the agar. So the first one is .4, so 14 millimeters. B is going to be still at 1.6, so 16 millimeters. And then C, I'm going to measure the full ring. So we're at 2.4, so 24 millimeters. We have 15 more minutes for the 60-minute measurement. So stay tuned. All right, we made it to the 60-minute mark. I'm gonna picture what it looks like from overhead. Okay, now we're going to measure it for our final measurements. Starting with A, we are going to measure, and we are still at 1.4. So 14 millimeters for A, which is the 0.01% methylene blue. And then B is still at 1.6, so 16 millimeters of 1% methylene blue. And then the final one, we're going to measure at, it's hard to see, let me move this. We're at 3, so 30 millimeters. Those are our final numbers for the potassium permanganate. Here is my chart. So this is A, which is the 0.1%, B, which is the 1% methylene blue, and then C, which is the 0.1% potassium. So make sure that you fill this chart out in your lab manual and answer the questions in your lab manual and be prepared to complete the homework assignment. The diffusion and the effect of molecular weight and concentration gradient.